Okay, so a square with a length 10 units shown on the diagram. Point A is chosen on the diagonal of the squares. The two shaded squares are constructed as shown, but choosing different positions for A showed us possible to change the value of total area of the shaded region. So what I was looking for us to do here, guys, is basically if I was to choose a rectangle, and I'm just going to make this diagram again for us. Then I'm going to grab this line here. Then I'm going to make another rectangle here, like so, and then another rectangle here. So, what basically wants me to do, if we can just grab all these, bring it all over here, and I'll also bring that over there. Now, if I was to grab the rectangle here, and what can happen is I can just rotate it so its corner is here. What I'm basically saying is when I move to point A, I can make this bigger or smaller, and likewise on this one here, this rectangle here, that is, I can basically make both of them bigger or smaller. So what we're looking at is the area of the rectangles that are beside it. So we can move this value all the way down here. Now if we made it really small, you can see that the area of the shaded region would become so much larger. So, and yet when you go the other direction, it's the same deal. The area of the two rectangles comes big. So what I'm thinking of is got to be the midway point. If you look at the midway point, that's where you have the most shaded area. So this area here is biggest at the midway region. Okay. So, what's the minimum possible value of total area of shaded region? Justify your answer fully. Well, I would say that position A midway, so as to maximize, or so as to minimize the area taken up by the shaded squares. Okay. Therefore, the area of these is going to be 5 in width, 5 in length, 5 in width, 5 in length. So area of one square equals 5 multiplied by 5, which is 25. And then total area of two shaded squares equals 50. Other possible areas, we could say, other examples are, so when you do another example, we could say is this, you could position this one down so it's a length of 2. Two here and 2 here. You can position this one here. So that one's 8 and 8. So 8 and 8. So our examples is 2 multiplied by 2 plus 8 multiplied by 8. That's 64, and that gives you 68, and 68 is greater than 50. Or 4 multiplied by 4 plus 6 multiplied by 6, and once again that will equal 60. 36 plus 62 is 52. 52 is greater than 50. Hence, putting A in the middle results in the smallest area. Minimum area. Okay. Now, The diagram below shows the same square. The diagonal of one rectangle is also marked. The length of the diagonal is d. Show that the total area of the two shaded squares is equal to d squared. Well, let's call this x and let's call this y. The area of this one, area of small square, equals y multiplied by y, which is y squared. Area of large square equals x multiplied by x, which equals x squared. This is a right angle triangle, so dy and x. So area of shaded squares equals x squared plus y squared. By Pythagoras' theorem, x squared plus y squared equals d squared. This is using this triangle here, hence the area of the shaded regions is d squared. The first three stages of pattern are shown above. Draw the next two stages. Well, I've already done that. Okay guys, question 11. The graphs of the two functions f and g are shown in the coordinate grid below. The functions are this one here and this one here. It says match the graphs of functions by writing f or g beside the corresponding graph in the grid. Well, look, what I'm just going to do is I'm just going to go straight into my my table function. I'm going to write this down here. X plus 2 squared minus 4. I'm going to do a region of minus 5 to, I don't know, plus 6. And this is the f function. Now I'm going to look at my points. Minus 4, 0. Minus 4, 0 is here. And then keep going along. Minus 3, 3 down here. And then we have 0, 0, which is here. So this makes this one by logic f, and by process of elimination the other one is g. Write down the roots of f and the roots of g. The roots of f and roots of g is where they hit the x-axis. So the roots of f, for f it's x equals minus 4, which you can see here, and then y and x equals 0. For g it's going to be x equals 1 and x equals 5. Okay, next question, next part. Sketch the graph of x minus 1 squared minus 4 on the coordinate on the graph above. So x minus 1 squared minus 4. And this is h of x. Once again, just going to go to the calculator on this. I'm going to change it to x minus 1 squared. It's 4. We're going to just draw some points here. I did a syntax error. What do you mean? So that's just this negative here. And what we get here is we'll just look for the x-intercepts. Minus 1, 0, which is here. I'll do it in green. Minus 1, 0. Next one after that, 0, 3 down here. After that, 1 minus 4 just down here. And then after that, we're gonna get so there's 2 minus 3, which is here. 2 minus 3, then we're going to get 3, 0, then 4, 5, which is up here, and then the other one's going to be minus 2, 5, and then we have our green diagram drawn as shown. There is there, h of x in the middle. Okay, so that's that one done. P is a natural number such that this side equals this side here. Find the value of P. What we're going to do is we're going to multiply it out. So we're going to get x minus P squared minus 2. So we're going to have x minus P multiplied by x minus P minus 2 equals x squared minus 10x plus 23. And what we're going to get is x squared minus 2px, or it's going to be minus px plus p squared. That's it there. Now we're going to match them up to both sides. So look at this. X squared equals x squared. Minus 2px, this one here, has to equal this one here. Therefore p minus 2p, cancel off the x's, equals minus 10. P equals 5. Write down the equation of the axis of symmetry of the graph of the function x squared minus 10x plus 3. Axis of symmetry of this graph here. So x squared minus 10x plus 3. So give me 1 second. The axis of symmetry occurs at its lowest point and then goes straight through the middle. So it's a line that goes straight through the middle at the lowest point. So we're going to just find the lowest point using our calculator here. So we're going to say shift x squared minus 10x plus 23. Start at these numbers here. Let's have a look. So dropping down 0, 23, 2, 7, 3, 2, 4 minus 1, 5 minus 2, 6 minus 1. Now, I'll just go a bit higher this time, alright? So just go, instead of 6, I'm going to stop at 10. And look what happens to the numbers. We're looking for the minimum value of the y function, because it's when y is at its low. So just keep going down. And look, we can see that the minimum value is minus 2, 5 minus 2. And then it goes back up to 6 minus 1 and goes up to 6, 2. So the minimum value is 5 minus 2. So this point here, if you will, just shift this to the right. This point here is the point 5 minus 2. And what we want to do is find the axis of symmetry of the line going through here. And this is a vertical line. So because it's a vertical line, it must be the line x equals 5. Because x is 5 for all of these points going up this way. Okay, explain why the graph below does not represent a function of x. Well, it doesn't represent a function of x because x values are mapped onto two different y values. And that's not allowed because the x value of, let's say, I don't know, 1 gives you this y value up here and this y value up here, and that never happens, okay? So for a function, any input in the domain can only be mapped onto one output in the codomain. Okay, and that's us, guys.